Hello, dear students. Once again, welcome to this YouTube channel. So, today we are to discuss some important terms from moving charges and magnetism. So, first one is magnetic force. So, what is this magnetic force? Already all of you know a charged particle which is moving in presence of magnetic field that will experiences a force, and that force is called as the magnetic force, and the maximum force experienced by the charged particle is QEB. If theta be the angle between V and B, then the magnitude of the force is QEB sin theta. So in vector form we can write Q times V cross B. So the direction of force is perpendicular to V and B. Okay. So in short, what is magnetic force? Means when a charged particle moving with a velocity v in a region of magnetic field B, the magnetic force on the particle is F equal to Q times V cross B. Okay. See, there are some special cases. If theta equal to 0, okay, so theta equal to 0 means the direction of the motion of the charged particle along the direction of the field. So that is theta equal to 0. So then definitely the force experienced by the charged particle is 0. Similarly, if the motion of the charged particle is opposite to the direction of the field, so it means it is also parallel but opposite direction, and that one is called as the anti-parallel. Okay. So that is theta is 180 degree. Sin 180 is also 0. So therefore the force on that charged particle is 0. Okay. So if the charged particle is stationary in a magnetic field, that is velocity is 0, then magnetic force is 0. Magnetic force is 0. Okay. So the magnetic force on the charged particle is maximum when the angle between V and B 90 degree, or the motion of the charged particle is perpendicular to the direction of the field. So that is theta equal to 90 degree and sin theta is 1. So therefore the maximum magnetic force on a charged particle is QEB. Okay. And the path traced by the particle is a circle, because the direction of the force is perpendicular to these two. Okay. If theta is not equal to 0, 90 or 180, then the path traced by the charged particle is helical. Okay. Now let us to discuss motion in a magnetic field. So the terms radius, period, frequency and angular frequency of rotation when a charged particle move in a circular path in a uniform magnetic field. See, if the charged particle is moving in a circular path, so that is theta equal to 90 degree, then the force experienced by that charged particle is QVB, and one more force, that is centrifugal force on the charged particle, and which is equal to mv square by r. See, so if both are equal, then we can write, or simply by equating the centrifugal force with the magnetic force, we can write R is equal to mv square upon QVB. So V get cancelled, so finally we can write R equal to mv divided by QB. Okay. Now the term period. Period means time taken to complete one circle. Okay. Suppose T is the time taken by the particle to complete one rotation. So speed is distance by time. So the distance covered by the particle is 2 pi r, and the time is t, and the ratio is v. So therefore T equal to, we can write 2 pi r, that is distance, that is circumference of the circle, divided by velocity. So we have already known the radius as mv divided by qb. So that is 2 pi m divided by qb, because v get cancelled. So this is the expression for period. Okay. Now come to the term frequency. So frequency means reciprocal of period. So frequency is 1 upon t. Just by taking the reciprocal of t, we are getting f frequency, and that is qb divided by 2 pi m. Okay. Next, one more term, angular frequency. The term angular frequency omega means 2 pi upon t or 2 pi f. 2 pi f, already f is known, simply multiply with 2 pi to the f value, we are getting omega. So that is 2 pi get cancelled. So simply we can write qb divided by m. See, qb divided by m. So these two are the expressions for frequency and angular frequency. Okay. So now we go to the term magnetic force on a current carrying conductor. See, when the conductor, which is kept in place of magnetic field of length L carrying current I, that conductor experiences a force, and the force experienced by the conductor is I times L cross B. So L cross B is magnitude of L, that is length, magnitude of B means field, into sin theta. So the magnetic force experienced by the current element is BIL sin theta. BIL sin theta, where I is the current in the wire, L is the length of the wire, and B is the, or theta is the angle between the direction of the current and the magnetic field B. Cleared? Okay. Now we have to discuss one important question. So this question was asked in many times. The question may be like this: state and explain Biot-Savart law. State and explain Biot-Savart's law. Okay. See, it is very simple law. If you know the expression, so dB equal to mu naught by 4 phi I dl sin theta divided by r square. If you remember this formula, so then easily we can explain the Biot-Savart law as well as the statement of Biot-Savart law. So the numerator quantities you can use directly and denominator inversely over. So by using the formula, okay, easily we can write the statement of Biot-Savart's law. So the statement is magnetic field, okay, at a point due to the current element, okay, is directly proportional to the magnitude of the current element, okay, magnitude of the current element I dl. And also directly proportional to the sine of the angle between, see, sine of the angle between IDL and R. What is this R? R is the position vector of the point, and inversely proportional to the square of the distance between the current element and the point. Okay, so that is dB proportional to IDL sin theta upon r square. So therefore dB equal to some constant IDL sin theta by r square, and that constant is usually denoted by the symbol mu naught upon 4 phi. So the value of mu naught is 4 pi into 10 raised to minus 7 Tesla meter per ampere. Is called, this mu naught is called as permeability of free space. Permeability of free space. Okay. So here in this figure, so xy is the current element, xy is the current element. Choose the conductor of length dl, carries the current I, and the current element is IDL. So to measure the magnetic field, at a point P which is at a distance r from the current element, and the angle made by the position vector and the tangent to the conductor, okay, is theta. Theta is the angle between the tangent drawn to the current element and the line joining between current element to the point P. Okay, so therefore we can write this as mu naught by 4 phi I dl sin theta by r square is the magnitude, okay, and in vector form dl cross I you have to write, okay. So db, vector db equal to mu naught by 4 phi I dl cross r divided by r cube, okay. So this is the Biot-Savart law, so very important law, okay. If you are perfect to explain Biot-Savart law, then definitely we can derive one very important question, so that we can discuss in next class, okay. So practice it properly, okay. Thank you.